Okay. Hello everyone. In the previous video, I discussed very briefly about the turbojet. That is, we have seen what is our aim to solve a problem. Now, let us discuss, let us do the engine analysis. First, compressor inlet condition, which is the exit of diffuser, which is this stage specifically. So, let us assume constant gamma throughout a particular process. Now, as there are no heat addition or heat losses, we'll say that this T naught 2 is Ta into 1 plus gamma minus 1 by 2 m square, and we know that this is true for any adiabatic process in general. And then we know that eta d is h naught 2 s by minus ha by h naught 2 minus ha. And then after doing some simplification, we'll get this p naught 2 by pa as 1 plus eta d into t naught 2 by ta minus 1 into gamma t by gamma d minus 1. And I have used one relation here. This P naught 2 S is P naught 2. Like our aim is to find at that pressure how my stagnation temperature is different or something like that. Okay. Next comes the compressor outlet condition, which is the process which is happening in the compressor. Again, same story, similar story repeats, and I'll get this equation. And we should note that this is not exactly 1.4 due to the because the temperature is high, and because of that there will be high vibration modes. Next comes the next comes this calculation fuel air ratio, that is during the combustion. We invoke the conservation of energy principle, which is the energy into the system. What is energy into the system? This is energy which is at 3 plus the heat which is coming from the combustion. This should be equal to energy at 4. So using this, we can find the fuel air ratio. Again, for a real burner, we have to add the factor of eta b in this. And we sometimes typically say P naught 4 by P naught 3 as the burner pressure ratio. Next comes the important part, turbine outlet condition. So I know that I know T naught 4. Now, this turbine supplies the power required to run a compressor. So the work done by the turbine should be equal to the work done on the compressor. So this m dot t into h naught 4 minus hs, h naught 5 is the work done by the turbine, and m dot c into h naught 3 minus h naught 2 is the work done on the compressor. Now I'll use an approximation that m dot t into cpt is approximately m dot c into cpc, because now fuel is added to burner, this m dot t is greater than m dot c, and then this gamma c is greater than gamma t usually. So because of this, I can typically use this approximation and finally get my T naught 5. And after getting T naught 5, again I'll do the same story to get P naught 5 by P naught 4. And nozzle inlet condition. Suppose if there is no afterburner. If afterburner is present, you have to modify it slightly by considering the effect of afterburner. Like again by doing this, again by doing the fuel air ratio at the afterburner, calculating that. If no afterburner is installed, then T naught 6 is T naught 5, P naught 6 is P naught 5. That is, there won't be this curve. So I'll get I'll get the inlet condition as like this. Now the exit condition, we know that this H naught 7 is H7 plus UV square by 2, which is the definition of stagnation enthalpy. And then for the steady adiabatic flow, I'll get H naught 7 is the same as H naught 6, because stagnation temperature is constant in an adiabatic flow. And then after doing some simplification, you will get this exit velocity as this. I would suggest you to remember this equation. This equation you need to remember. Rest all equations you need not remember, but still if you want to remember, I would suggest you to remember this. So, and also I've used one important thing. Nozzle exit flow is unchoked. If the flow is choked, then you have to be careful. You have to use the choking conditions. So that's it for this video. In the next video, I'll be discussing about this turbofan engine. See, like we have found this UE and UE, UNF. So from this, I can definitely find T by M dot N TSMC. Again, I told this is an unchoked nozzle. For choked nozzle, you have to do a slightly careful. You have to be slightly careful. I guess that you can easily do that. Basically, your gas dynamic stuff only. Okay, thank you.